So we asked to evaluate this integral. So we notice we have a square root sign and 36 minus x squared. It might seem difficult, but we'll use trigonometric substitution. So we draw the triangle, and this is the larger side. So this will be the hypotenuse, which is square root of 36, which is 6. And our x will be the opposite sign, and therefore the adjacent side to the angle would be 36 minus x squared. And now we let sine of theta is opposite of a hypotenuse, is equal to x over 6. And then we differentiate this, we get cosine of theta is equal to dx over 6. And finally we go we can also go cosine like this. We can just say cosine of theta is also equal to square root of 36 over x squared over 6, because it's adjacent over hypotenuse. That's cosine by definition. So we can just say 6 cosine of theta is equal to the square root of 36 minus x squared. We just multiply by 6, right? So this will just make it easier to substitute back. So now we have 36 minus x squared is equal to 6 cosine of theta. We can just substitute back here. And for dx, we just multiply by 6. We get, this should be d theta rather, because when you differentiate, you should get d theta. Just multiply by 6, and you get your dx. And so you substitute for dx. So what did you say dx was? So dx is 6 cosine of theta d theta. So we go 6 cosine of theta d theta. And we have to substitute back for 36 minus x squared. So we also get 6 cosine of theta. And now we just divide. We just cancel these two, and essentially we get d theta, which will give us what's the antiderivative of 1? Well, it's theta. It's whatever this is, and plus c. But now, what is theta? Theta is just sine minus, well, it's the arcsine. If we go sine minus 1, then we cancel these two cancellation identities, you get theta. And of course you have to do the same thing on over this side. So theta is equal to sine, arcsine of x over 6. And so when we substitute back finally, we get sine minus 1 of x over 6 plus c. And that's the final answer.